Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're into the first round of replacing some parts and doing some rewiring inside this amp. And there's a couple of things to note here. One is we're doing kind of a multi-stage or multi-version video series. You don't have to do all of this stuff. Some of these things were like replacing the components, like these resistors that I really now feel like are substandard quality, which they work, but they're not the best. And I think we can see some real improvement using some higher quality metal film resistors from these metal oxide ones. Even some of the resistors that are in very low current positions inside this amp that are nowhere near any kind of voltage limits are going to be having over 2 watts of power no matter how much voltage is run through the amp, or cracking and doing weird stuff. So I feel like that, that's a really good starting point for any build, is to replace all these resistors. Now I'm also going one step further in this one that I'm working on and replacing some of the wiring with what I consider is best design standards. And Morgan Jones wrote a really good book, Building Valve Amplifiers, and I'll put it in the description. It's not a cheap book. It's pretty thick, but if you really want to understand the hows and whys of doing the wiring and the lead dress and why components need to be placed in certain positions inside the amplifier, this book's like the gold standard on it. And one of the things that disturbs me is I'm seeing a lot of the 110, 220 volt wiring that are just a parallel pair of wires, which you should never have AC wiring in a tube amp that's not a twisted pair. And we're going to be eliminating the 115, 230 volt switch because this amp's never going to be used in another country, and direct wiring up the power transformer to the IEC socket and then up to the switch using twisted pairs of solid gauge wire. Probably going to be doing some of that with the heater. Is that necessary to do on every build? Absolutely not. So you can kind of pick and choose at what comfort level you are at modifying your amp on what parts of this you want to do. And I'll try to explain which ones seem to be having the most impact. So with all that said, let's get to work. Okay, in this video we're going to be working on the power supply, namely this little section here underneath the power transformer. And what we've got going on here is these 3 terminals here are basically like a tag strip. They're not connected to anything in the power transformer. They're just used to, connect these components to. And this terminal here is connected to the high voltage B plus off the second cap after the choke. And this resistor and this resistor, which is going to ground, and this is high voltage B plus, this is creating a voltage divider that then comes over here, and these 200 ohm resistors are going to the heaters that go to the input or the front section of the amplifier, and this creates a virtual center tap right here between these 2 resistors that then is in the center of this voltage divider to raise up the offset or the heater center tap to be closer to what the voltage is that's going to be on the cathode of some of the input tubes. Normally you would pick, let's say one of the cathodes is at 150 volts and the other one's at 0. You'd raise this up to about 70 volts, so it would be halfway between the two, because you're not supposed to have over 100 volts between the cathode and the heater. And that's what they're doing here, is to make sure that doesn't happen. And I'm going to be measuring this voltage just to see what they've set it at before we start changing all this. But I'm going to replace all these resistors. This cap is going from the center tap to the ground, which is commonly done. So this cap's not super important to be like some crazy audio grade cap, because it's just on the heaters, which really aren't connected to the signal path. Now this cap here, this diode, this resistor, and this cap is creating the negative voltage to use on the grids of the output tubes. And so definitely want to put a nice cap here. And this is doing a halfway rectifier to make the negative voltage on the grid. So this is an important part of the amp. Now I did forget to order this guy, and obviously this green versus these gray ones, I believe this is a wire round resistor. And so I'm going to measure this value while I'm in here and then order one of these on my next Mauser order. But for now we're leaving this one alone and just replacing this cap. And again, this cap and all these resistors. This guy here is the dropping resistor between the B plus that's going to the output tubes and the power that's going, or the B plus that's going to the front end of the amplifier. Now I've seen this fruit mod that I think it was on stereo.net where the guy's putting a film cap on the input tubes. And while I get what he's trying to do to separate the two channels from each other, or have a capacitor that's kind of helping keep them from interacting with each other, a much better way is to dual rail the power supply going into the front of the amp, so that in essence you'd have two of these resistors and two caps, that one for each channel, so that there's no way that there's any crosstalk between them, which is basically why people build monoblocks. So anyway, that's a future mod. Today we're not going to do that. We're just doing an upgrade by replacing this resistor, and we'll mess with that later in the future. But see, another thing that I want to deal with while I'm working on the power supply. Let me zoom out so I can show you this. Okay, what we're looking at here, we've got this switch right here that is for switching from 115 volts to 230 volts. This amplifier is only going to be used on 115 or 120 volts, but it's in the US. And I get why they put the switch in here. So, a retailer can pop the bottom cover off, flip the switch, and it can be sold in a different country. But the problem is you've got all of this high current AC wiring, none of it's twisted, and it's running right by the speaker jacks, and especially this guy. It's running up here to the front switch on the amplifier, and it's just a pair of wires inside this sheathing. This isn't like a shield or anything. That's just kind of some heat shrink tubing that they've put on here. And this needs to be a twisted pair of wires going up to the front switch. Okay, it's time to get in here and start doing some soldering. So first I'm going to do is remove this cap right here. Come in here and get that up, pull that little guy out. Then the next thing I'm going to do is remove these two 220 ohm resistors. Go. And take this one out. Okay. Then we're gonna kind of go in here and put the new ones in. Make sure we get all our wires connected back. Solder this little guy in. Then trim off the extra lead here. Solder that joint there. And get the next one. Bend the lead over. Okay, get that out of the way so I don't burn that wire up. And then we'll come back and solder these heater wires back to that terminal after I get these resistors in place. Solder this joint here. That. Then we'll come in here. Try to do this where I don't get in the way of the camera. Solder this lead back on. I got a little blob of solder on that wire. Pop that off. Bend that up. So we got these are two 220 ohm resistors that create the virtual center tap that this voltage divider will then raise this up to 60 volts DC. So the next piece I want to put in is this 33K resistor. Okay. So what we may do here is, okay, there's that end of that. I'm going to cut this right all flush like that. And then while we're here, let's go ahead and replace this 220K resistor. And pull out this 1K one as well. So we will next come in and put the 33 ohm resistor, or the 33K resistor across here. Bend it over like that. Like that. Like that. We're going to go ahead and solder all that together. Then all we have left is to come across here. We're going to solder that little guy in there like that. I'm going to go ahead and put a little solder right here on this corner here. So then I can just come in with a little bit of solder blobbed on the end of that soldering iron. Solder that connection. So then we're going to have this wire going back down here. Then we're also going to have then our 1K resistor going from this terminal to that one. And then we'll put our cap back in place. And then we'll have this voltage divider circuit that is putting the DC offset on the driver circuit heaters, all redone with new resistors and new capacitors. We want to get that resistor in place. I'm going to put a little fresh solder on the end of this wire so it's all ready to go. Solder all three of these little parts here together at once. wire here is not really soldered too great. Let's come back in and heat this up. I'm sorry if I'm kind of blocking your view here, guys, but I got to get in here and solder this. Come in here and make sure we don't have any weak solder joints. Everything looks good. Okay, so the next thing we need to do is replace this cap here. And hopefully this isn't too hard to desolder here. And then pull this other lead out. And here's one of our caps. We'll make sure the negative goes to the ground. And this guy's going to sit. It's going to sit in here, kind of underneath that stuff. It's going to sit just like that. One side. The other. And actually I soldered that in backwards. Well, bummer. I forgot this is a negative power supply. So when you're doing this, remember that because it's a negative power supply, the ground is actually the positive. So let's hope there's enough. I think there's enough capacitor lead that I can do something creative here and connect this thing. Because really all we got to do is we can jump over to that little leg right there. One of the fun joys of working on camera is trying to make sure that I'm not doing something stupid while I'm showing you guys how to do this, but I think sometimes showing these little mistakes can be helpful. There we go. So solder this side up first. That. Glad I caught that, or we would have had a nasty little surprise when we powered this up and the capacitor exploded. And then the last one we have to put in is this little cap on this side. We cut these leads off. Load up a little solder on that little corner there and on that little piece. And this time, because this is a positive supply, we're definitely going to have the negative to the ground on this one. And there we go. We're all done placing all of our resistors and capacitors on this underneath of the power transformer. Now the next thing that I'm going to be doing is rewiring up this main power thing to get rid of this switch. So I'm going to unsolder all these connections, get all these wires out. I'm going to be unsoldering these wires here, and then the wires over here to the IEC connector, and then we're going to be removing this wire here that goes up to the power switch and replacing it with a twisted pair of wires. So off camera, I'm going to unsolder all this stuff and make up my new twisted pairs of wires and come back and show you soldering that stuff in. So we're ready to redo these power leads. So I twisted up some 18 gauge solid core wire, and they're going to run up here to the power switch here in the front, and then it's going to be tucked under the corner of this edge here up high away from all the signal wiring, and then come down to our IC connector here, and you want to make sure that the fused lead is going up to the switch. So the switch ever shorts out for some reason or something happens to this wire going up the switch, it'll blow the fuse. I've seen people wire it backwards where they put the fuse in the return wire for the transformer, and that's not how you want to wire it. And then we come over here, and then we've got these laid out so they'll bridge across these terminals, which will put these two primary windings in parallel with each other for operating it on 120 volts. So probably going to zoom in and kind of show soldering up each of these connections. Like I said, zoomed in so you can see it better. Okay, had a little video issue. I think the camera might have gotten a little hot and turned itself off while I was doing the soldering of this new power leads. Had it happen before, and fortunately I wasn't really paying attention and looked up and the video wasn't recording. So luckily this isn't rocket science stuff, and so I can show you what I did with this new power lead. We replaced the switch and all this other wiring that was connected with that, changeable between 120 and 240 volts that this amp had, because we're only going to be running this thing on 120 volts here in the US. So got some 18 gauge solid core wire, twisted it up, ran it over here to the IEC connector, and then ran another pair of wires along this edge here up to the power switch, and it's away from all of the signal kind of wiring down here in the bottom of the amp. And so I'll zoom in here and show you how I bridged this transformer to put the two primary windings in parallel. If you were running on 240 volts, they would be in series. Anyway, the other thing too is I moved the bridge rectifier up here to this little stand that used to be for the switch, and we freed up this little guy here. And let me zoom in here and show you that. So we moved the bridge rectifier. It was on this little stand up here, and I moved it to the stand where the switch was, or one leg of the switch was, and then I twisted this pair of wires too, because I'm not sure why they just were running these 240 volt high current wires up to this bridge rectifier without having them twisted. I mean, once it gets on the other side of it, it's DC and it doesn't matter, but all the AC wiring should be twisted like this, just like they did the heaters. So we moved this over here, and this gave us this spot here to use for the future star ground point when I get into redoing the grounding inside the amp. So, and then let me zoom in here and show you how the wiring on the transformer was done. This is the 120 volts coming into the transformer after the switch, and it's soldered onto this terminal and then bridged over to this one, and then it's soldered onto this terminal and bridged over to that one. And that puts the two primaries in parallel with each other. And again, this is for using the amp on 120 volts, and it gets rid of the switchable voltage deal with all that extraneous wiring that involved. As you can see, that really cleaned up a whole mess of wiring over here, and we're going to be doing future cleanup of the wiring. I really don't like the way they've done the heaters. I'm not sure why they ran the 6.3 volt heaters going to the front end of the amp, like up and over and across, and why didn't they just run them straight up the center of the amp? So that's probably going to be something else we do here on a future episode, but I think this is a good place to wrap this video up. Well, as you can see, we've really cleaned up the power supply section of this amp, and I'm really happy now to have these twisted pairs of wires powering up the power transformer and also going to the bridge rectifier. And we've got these resistors replaced that were cracking, and while they still measured right, I have to believe that that's just not good, that the resistors insulation's coming off of them. So got these high quality metal film resistors in, got new caps in. I went with some audio note caps. Nikon would probably be fine if you want to just order everything through Mauser, but since I was already doing a order with parts connection for the film caps, I went ahead and ordered some of the kind of budget audio note caps. I don't see any point spending a fortune on the caps, especially in this little power supply section, because it's basically doing the DC lift of the 6.3 volt going to the heaters on the input tubes, which really shouldn't have a lot of sonic impact on the amp. That said, after doing this work that we did here, plug the amp back in, the little bit of hum, and again, guys, I'm not talking about going brrr kind of hum. This was a very, very tiny bit of hum at the mid volume point that you had to put your ear just up against the speaker to hear. It's almost gone. It's made another level of silence from the amp, replacing these resistors, and I believe putting these twisted pair wires going to the power transformer is removing the AC noise inside the amplifier. And so that's a win. Going forward, going to be working on the heater wiring a little bit, which again is optional. The heater wiring that's in it's not horrible, but it could be done better. And we're trying to take this light to the next level. But the main thing we're going to be doing is replacing all the resistors and capacitors in the front end of the amp. I've already started reverse engineering what is in the amp, and I don't know about you guys, I've had a hard time finding a really good schematic of this amp. There's one real blurry one that I found on stereo.net that you can't read any of the values of, and then I've seen some hand-drawn ones, and neither of those that I found matches what's inside the amp. For one thing, the voltage regulator tube is not in series. The two triodes are not in series. They're parallel, at least in this newest version of this amp that I've got. And there may be different versions of this amp out there where they wired some things differently. And so I can only, discuss what's in front of me, and this amp doesn't look anything like what is in that stereo.net, that Australian website's schematic that I was able to find. So I'm going to put together a legit schematic of what is in the amp as delivered today so that we know where we're starting from. And then I already see some cool mods that we can do to this thing that are going to help it sonically, that should be pretty easy to do. And I think they're called the fruit mods on that stereo.net. And I understand what he was trying to do. And when I first saw his mod and I was looking at the schematic that is on stereo.net, it didn't make any sense. But the amp's not wired like that schematic. And so what he did to the amp was trying to isolate the two channels. I think there's a way to do that much better than adding a couple of film caps in here, without doing a ton more work, especially if you're already in here replacing these resistors and capacitors. So I'm really positive that we're going to be able to do some nice improvements on this amp, and it's already sounding better. I do hope you're enjoying this content. If you are, please subscribe to the channel so you get updates when new content comes out. I think there's a little bell thing you can click to that'll go ding when new content comes up, so you'll see when this video is published. And also like the video. That also helps it propagate through their system with algorithms or whatever, and gets this in front of more people so they can learn cool stuff about tube audio. So anyway, we'll see you soon. Have a great day.